Hello, ladies and gentlemen. Welcome back to Math 30-2 Midterm Review, Part 4A, Chapter 4, Rational Expressions. So, let's begin. Write an equivalent rational expression for each expression below, and state the non-permissible values. I'm going to do the non-permissible values first. For this one, for the denominator, cannot equal 0. So, I divide both sides by 9. A cubed cannot equal 0. Now, how do I get rid of a cube? Well, I cube root both sides. The cube root of 0 is 0, so A equals 0. All right? That's the non-permissible values you got to remember. Now, as for simplifying, I kind of like splitting it up. So I will tend to write 18 over 9 times A squared over A cubed. Right? And then I look at both of them. 18, don't do that, don't do that. 18 divided by 9, I divide top and bottom by 9, and I get 2 over 1. And then I look at A squared and A cubed. Well, I got 2 A's on top and 3 down below, so I can cancel out my A's on top. And cancel out 2 of them, so I'm down to A to 1, or just A. It simplifies to 2 over A. A cannot equal 0. Okay? Now, let's look at the second one. 6x divided by x minus 3. Now, right off the bat, my non-permissible value, my denominator, x minus 3 cannot equal 0. So then I add 3 to both sides. I'm going to solve for x. So I get x cannot equal 3. Okay? Now, as for simplifying, since it's x minus 3, I have to factor stuff out from every term, and I can't. X minus 3 is as simple as it gets. But look at the question. What am I asking you to do? Write an equivalent rational expression. So, this becomes important later. But what I can do to this is multiply top and bottom by the same number, say 5. 5x, because then I'm putting it in the denominator, which is going to screw up my non-permissible values. So that's 5 times 6 is 30x over 5 times x minus 3. And once again, right, so first thought is to cancel stuff out, but you can also multiply. Right, so far so good? Good. Now, let's just do some practice here. Determine the non-permissible values for each rational expression. 2y minus 1 equals 0. Add 1 to both sides, because you want to get y all by itself. So this is 2y cannot equal 1. Then you divide both. Now, notice it's 2y. You want to get y. So how do you get rid of times 2? Divide both sides by 2. Right. Now, I'm going to pause the recording, and I want you guys not to simplify b, but just tell me the non-permissible values. All right, so pause the recording. Let's go. All right, welcome back. Now, 6x minus 12 can't equal 0. You'll notice I factored stuff out as 6. Some people will argue, but couldn't you just add 12 to both sides at the beginning? I don't want you doing it that way. Humor me. I'll show why in a moment. But please, factor out what you can first. And then we divide both sides by 6. 0 divided by 6 is still 0. We add 2 to both sides, so x can't equal 2. That's all I need you to do. Now, here's a question to make you think. Lisa claims that you can use multiplication or division to create an equivalent rational expression. Do you agree? Justify your decision using examples. Well, can you make an equivalent rational expression? Yes. What did we just do back here? We multiplied this by 5. I'm going to do this easy. I'm going to go copy. And oh, you fudge! No, don't put that on paper fudge. How do I do like that? That's not a good idea. Here we go. Repeating myself, I'm going to be lazy and not copy that again, but if you guys want to, you can. Since we're not multiplying and dividing by a variable, we're not changing, we're not changing, we're not adding another non-permissible value. Right? That's a sneaky one. So here, determine the non-permissible values for each rational expression, then simplify the expression. All right. So once again, minus 6x to 7 can equal 0. Both sides become 6. X to the 7 cannot equal 0. Take these 7 through both sides. X cannot equal 0. Alright? Now, can we simplify this? I certainly hope so. We have a minus 6 times x to the 5 over x to the 7. If I top multiply by 6, that becomes 5 and minus 1. 5x cancel out, this becomes x squared, so this becomes 5 over minus x squared, or minus 5 over x squared. X can equal 0. Don't forget your non-permissible value. I'm supposed to get real cranky about that. Alright? So to see how this goes? Oh, good. I'm going to pause the recording. I want you to do number 2, the second one. And note here, please, as we did back in 16, factor it, then find the non-permissible values, alright? That'll help. Alright, so factor it, and find the non-permissible values and simplify. If you're having trouble with it, you can watch the video, okay? Good luck. Actually, I'm going to explain this one as I go along. I realize this is slightly, it's kind of tricky. Slightly evil. Anyway, notice I can factor out a 10. I'll do that with 10. And I've got a squared minus 4 can equal 0, which is good. Now, here I want you to realize that's a squared minus 2 squared, or difference of squares. This is actually a plus 2 and a minus 2 can equal 0. That's why this is tricky and I'm doing it with you. So, a plus 2 can equal 0, a minus 2 can equal 0. So, 3 can equal 2, add 2, add 2, 3 can equal 2. Alright? Now, once you do that, we have to factor this mess. Now, 5a plus 10. Now, notice we just factored the top bottom. 10 times a plus 2 times a minus 2. So, 5a plus 10. Can I factor stuff out of that? Yes. 5 and 10, I can factor out 5. It's going to be a little long. You're kind of guilty asking you to do it on your own. And now what cancels out? 8 plus 2 cancels out. And 10 and 5, the top by 5, that becomes 1 and 2. So we're down to 1, 2 times a minus 2. And don't forget, a cannot equal plus or minus 2. And I'll write it like that just because I'm lazy. And because I can. Okay. So far, so good? Alright. Now, I'm going to pause the recording here. If you guys are having trouble with this, look at the examples again and give them a try. Shoot me an email. Otherwise, keep on going to the next video. Good luck.